Today I'll be speaking on the topic automotive fuels, and I would be basically covering two main fuels which are used in the automobile industry, that is the petrol and the diesel. So here I have made a presentation which basically covers all the points which I'll be taking up in this presentation. Firstly, I'll be basically talking about the qualities of a good fuel. So what are the qualities of a good fuel? A good fuel should have a definite auto ignition temperature so that it ignites at a particular temperature and does not and shows consistency in its combustion properties. Secondly, it should have a high energy density, or we can say high calorific value. It should have a fast combustion, so it basically permit the use of these fuels at higher rpm so that they can produce more power, and at the same time they should be less polluting in nature. Of course, these are hydrocarbon fuels and they are polluting in nature, but they should be kept to as minimum as possible, less toxic in nature. And the most important part is that the fuel used, they can be either solid or in liquid form, but the gasification of fuel is a must. That is, they should be easily atomizable and they should be able to mix with the air, and so that the combustion reaction can take place. So next I'll be talking about the petrol, or which is also called the gasoline, as you can see. So basically petrol and diesel both are obtained from the fractional distillation of crude oil, and whereas the petrol obtained is basically the lightest fraction which is obtained. So petrol is basically classified by the octane value. So what is octane? For that we need to know about isooctane and n-heptane. So isooctane stands for 2,2,3 trimethyl methyl pentane, whereas n-heptane is a straight chain hydrocarbon having 7 carbon atoms. So isooctane has been assigned an arbitrary value of 100, which is research octane number, the RON. So now I'll have to talk about to explain RON, I'll have to go into RON and MON. RON stands for research octane number and MON stands for motor octane number. So research octane number is basically the octane number which is found out when the tests are carried out under mild conditions, and MON is basically the octane number which is basically found out when the operations or the test for that fuel are carried out under severe conditions or extreme conditions. So what that basically means is that the MON value of a fuel would certainly be less than the RON value. So here we'll be talking about RON values, and in general the fuels are basically compared based on their RON value. So isooctane has been assigned an arbitrary value of 100 and n-heptane has been assigned an arbitrary value of 0, and this is because of the fact, as you can see, the RC values. RC value for this is the compression ratio value. The upper limit for the compression ratio is 10.96 for the isooctane, and n-heptane for n-heptane we have 3.75. So what a critical compression ratio basically means, it basically stands for the highest compression ratio above which the successful application of the fuel is not possible, that is, it may cause knocking. So this is the highest allowable or highest permissible values for the compression ratio. So the next property of the fuel is the auto ignition temperature. So now auto ignition temperature is that temperature above which the fuel gets automatically ignited without any external aid. So for the petrol we have 280 degrees, that's the general auto ignition temperature, and the next point is the next property rather is the flash point, which is 43 degree for the petrol. So flash point is basically the temperature above which the vaporization of fuel starts. So obviously the flash point has to be less than the auto ignition temperature, because first the fuel will vaporize, it will mix with air, and then the combustion reaction will take place when a temperature greater than 280 degrees would be sustained in that region. So that's with the auto ignition temperature and the flash point. Next we come to the blending in fuels. So generally the fuels available in the summer season and the winter season they vary because of the difference in temperatures. There is difference in the volatility of the fuels, but we know the volatility of the fuel should be a constant for the engine. So for that what we do is we add butane, which is C4H10, as you can see in this figure, and butane addition basically leads to an increase in volatility. So basically in the winter season, when the volatility of the fuel is generally less because of the decreased temperature, we increase the addition of butane, whereas in the summer season we limit the amount of butane added. So next we come to the diesel fuel. After the petrol, we come to the diesel fuel, which is also called the fuel oil, as you can see. So obviously it is more dense than the petrol, and what that means is for the same volume of the fill, you're getting more mass of diesel compared to petrol, and this is the reason why more average of fuel economy is derived out of diesel compared to petrol. So just as for petrol, we had the octane rating. Similarly for diesel, we have something called the cetane rating, and the general values for a normal quality diesel, as you can see in the figure, is 40, and for a high speed diesel it is 55. So basically, what is cetane rating? Cetane rating is a measure of the ignition delay of the fuel. It's a measure of the quality of the fuel. So what that means is, higher the cetane rating, lesser will be the ignition delay, which is beneficial in case of a CI engine, as we want less and less amount of ignition delay, so that there is no fuel accumulation and the combustion can take place in a controlled manner. So this is the normal quality, this for the normal quality diesel, and this is for the high speed diesel, and this permits the diesel engines to go at higher RPMs. Again, just as in petrol engine, here again we have the auto ignition temperature for diesel, which is 250 degrees centigrade, and which is understandable also, because it has to be less than petrol, of course, because in the SI engine the combustion is being initiated by spark plug, whereas there is no spark plug in this case. The combustion or the ignition process is taking place by the sole increase in the temperature of air only. So that basically justifies that auto ignition temperature of diesel should be less as compared to petrol. But again, now coming to flashpoint, it is 52 degrees as in case for diesel engine, whereas for a petrol it was 43 degrees, which is again obvious, because as we earlier said that diesel is more dense than petrol. So now I'll be talking about the anti-knock properties. So again, knocking may take place both in petrol and diesel vehicle. What is knocking? Knocking is basically the abrupt rise in cylinder pressure, such that there is an uneven or unsmooth or non-smooth delivery of power. So generally a compound called tetraethyl lead, whose density is 1.7 grams per centimeter cube, was initially used, which was added along with the fuel so as to increase the auto ignition temperature in the case of a petrol engine, and which basically what it did was that it increased the chemical lag by absorbing the heat of the reaction, and thus it increased the chemical lag or the ignition delay of the fuel, and this led to a reduction in the knock properties. But lead on the other hand has many harmful effects, as it is quite poisonous when inhaled by humans. So that is why the use of lead has been discontinued. So in place of lead, there are other additives which are added to the fuel in order to increase their auto ignition temperature. So after covering the anti-knock values, I move forward to a basic comparison between petrol and diesel. So here we'll be basically taking up cases. First comes when we put petrol in a diesel vehicle, and the second case will be when we put diesel in a petrol car. We'll be analyzing what happens. So in the first case, when we put petrol in a diesel car, we must realize this fact that petrol has a higher auto ignition temperature, and so what that means is that when it is injected in a diesel cylinder, since its auto ignition temperature is high, there will be accumulation of fuel, and this accumulation of fuel will ultimately result in an uncontrolled release of energy, because there will be accumulation of the fuel particles inside the cylinder, and once the temperature increases above their auto ignition temperature, then suddenly combustion will take place and there will be an uncontrolled release of energy, again leading to abrupt pressure rise, causing knocking. This is what we call the diesel knock. So what that means is that it is harmful and it should be avoided. Next we come to the case when we put diesel in a petrol car. So again, diesel has a less auto ignition temperature as compared to petrol, as I talked earlier, which was 250 degrees compared to 280 degrees in a petrol vehicle for a petrol fuel. So the auto ignition temperature is less. So this means the chemical lag is obviously less, and this means that the knocking tendency of the fuel drastically increases. Knocking tendency of the fuel increases. This means that pre-ignition will take place and the fuel will get ignited before the flame front engulf the whole part of the charge, and this will again result in an abrupt rise in pressure, and this will cause an erratic power delivery. So again, this will cause the petrol knock. So in conclusion, I can say that either ways, if you are diesel in a petrol car or petrol in a diesel car, please do not try it. It's very harmful. And with this, I conclude my presentation. Thank you.